Hello and welcome to Section 2 of the Mapping and Measurements module, part of the How to Manage Your Forest online series. My name is Tristan Huff. I'm an Extension Forester with Oregon State University, and I'm going to walk you through this section. Previously, in Section 1 of this module, we talked about the land survey system and how it locates your property in the world. We also talked about the various maps and aerial photos that are available to help in your inventory of the property. In this section, we're going to get deeper into the inventory process and go through the step-by-step process of creating an inventory for your woods. Finally, we'll talk about how forest products that come off your property are measured. You'll recall from Section 1 that there are lots of different things we might want to measure in the woods. For the purposes of this section, we're going to focus on the timber inventory. Remember though that no matter what you're interested in measuring, the same rules apply when you're designing your inventory. So, what exactly is a timber inventory? Basically, it's an estimate of what you have in terms of wood products. It could include the number of trees, the volume of wood, the grade of that wood, and also the species, all expressed on a per acre basis. Usually when we do a timber inventory, or in any inventory, we're going to base our numbers on a sample rather than a count of all the trees in the woods. Timber cruise is a term commonly used to refer to an inventory of the standing timber on your property. It's an estimate of the volume of the timber and also the quality of that standing timber. It can be part of a larger inventory effort, and it's often used as part of a larger property appraisal or in preparation of a timber sale. Okay, let's get into the step-by-step process of creating an inventory for your property. Remember, we're going to be talking about a timber inventory, but the same rules apply no matter what resource you're measuring in your woods. The first step is going to be to create a base map. Second, we're going to identify distinct management units that we're going to sample. Next, we're going to determine an appropriate plot size. Then, we're going to figure out where those plots are going to go and how many we're going to put out on the ground. Then we're actually going to go out in the woods and collect plot data. And finally, we'll summarize that plot data into a useful form. So, the first thing we need to do is create a base map that will guide our inventory. You want to include on this base map things like your property boundaries, roads, streams, other physical features, and also a north arrow, scale, and legend, things that should be on any map. Base maps are commonly made by overlaying features like roads, fences, vegetation, etc. on top of aerial photos or topographic maps. This can be done manually using plastic overlays, or they can be done on a computer. Once you have your base map in place, you can identify distinct management units which will help guide the inventory process. You'll start by looking for areas of similar vegetation type. Do this by looking for areas with similar color and density. Next, you'll want to use natural boundaries like ridges, streams, or meadow edges to help delineate the stands. You'll also want to include man-made boundaries, things like roads, fences, and clear-cut edges, because these are going to affect how you manage the units. You'll want to delineate units not only based on their vegetation cover type, but also on management considerations. For example, you're going to want to take into account things like access and the size of each management unit. And you'll also want to outline your management unit based on your specific objectives for those stands. Remember that, along with all of the rest of your planning process, delineating management units is a dynamic process and it'll likely change over time. Okay, let's look at an example of how we might break up a property into management units. This property is a little under 40 acres, and it's made up of a couple different ages of timber, and it also contains a home site. This landowner first divided the property into a north section and a south section. The north section contains a little bit older timber, and that timber is a little more variable. They also split this northern region into two different sides. The eastern side of the section was delineated out because it surrounds the home site, and so they wanted to manage more for aesthetic properties there. In the southern portion of the property, the stand is fairly uniform young timber, but there is a stream that breaks the unit up from east to west. The landowner decided that it makes sense logistically to break this stand up into two management units. There's also a road that runs north and south through this unit, so they decided to break up the eastern side of that road into its own management unit. Finally, each one of the management units was assigned a number so that it could be referred to in a management plan. Once we've broken up our property into distinct management units, we can go about measuring the resources that we're interested in. Now, we could go out and measure every single tree on the property, and that would likely give us the most accurate description of that resource, but that's liable to be way too time-consuming to make it very practical. So instead what we do is we sample the characteristics that we're interested in, and we do this usually by laying out plots on the property. A sample will give us an estimate of whatever characteristic we're interested in measuring. Now, it's important that when we're sampling something, that sample has to be free of bias, and we want to balance accuracy and work. In other words, we don't want to spend too much time measuring every tree, but we want to make sure we measure enough trees so that our estimate is accurate. When we're designing our sampling scheme, we need to remember that the sample we take should be representative of the management unit we're measuring. The sample should be either systematic or truly random, and this will help eliminate bias when we're laying out plots. We'll talk a little bit more about this later. When stands are very uniform, that is, if they don't have a lot of variation from area to area, we can have a relatively small sample, whereas in highly variable stands, that is, stands where trees are spaced inconsistently or trees are of a wide variety of sizes, we're going to need to take a more intense sample. When we're designing the layout for a timber inventory, the three things we need to consider are the sizes of the individual plots, the total number of plots, and the location of those plots. When deciding what size of plot to use for your inventory, remember that it's always a balancing act between accuracy and productivity. You're going to want to balance the amount of trees you measure with the time it takes to measure those trees. Bigger plots are going to have more trees and lead to a more accurate estimate, but they're also going to take a lot longer to measure. A good rule of thumb is to aim for between 5 and 8 trees per plot. So, what are some commonly used plot sizes in a timber inventory? A 1/10 acre plot is a pretty big plot, and it's usually used for large, widely spaced timber. A 20th acre plot is going to be used on smaller timber that's a little bit closer together, and a 50th acre plot can be used for really small trees that are fairly dense. We might even use a 100th acre plot, but this small of a plot is probably going to be reserved for either extremely dense stands or when we're surveying seedlings or recently planted trees. Another way to decide on the plot size to use for your inventory is to base it on the average distance between your trees of interest. If trees are on average less than 8 feet apart, you might use a 100th acre plot. If they're between 8 and 16 feet apart, think about using a 50th acre plot. And if they're widely spaced, say more than 16 feet or so, maybe use a 20th acre plot. This should get you in the 5 to 8 tree per plot range. Now, you don't need to decide on the plot size before you go out in the woods. You can actually decide when you're out there. You can put in a few plots at different sizes and see how many trees you get in each plot. But it is important that once you decide on a plot size, to stick with that plot size for the rest of the management unit. Okay, so besides the size of each individual plot, we also need to consider the total number of plots we put out on the ground. We want to put out enough plots so that we get between a 5 to 10% sample of each management unit. When stands are more uniform, we can probably get away with a 5% sample, but in more variable, patchy stands, we might want to use a 10% sample. When we're doing a 20th acre plot, 1 plot per acre is going to give us that 5% sample, and 2 plots per acre is going to give us that 10% sample. That's going to change based on the size of our plot. Once we've determined the size of each plot and the number of plots we want to put out in a management area, we need to set about locating those plots on the ground. Now, the best way to do this is through a systematic process, so on some sort of a grid. This should give us a more representative sample of what's actually out on the ground compared to just going out in the unit and laying out plots wherever you feel like. If you just put plots wherever looks like a good spot for a plot, you might inadvertently or subconsciously put plots where trees are bigger, where they're more open, or even where there's less brush. The key thing when sampling a management unit is to avoid plot selection bias. When laying out plots in a grid, it's useful to think about the distance between those lines and the distance between plots within those lines. The various spacings we use between plots and lines will determine how many plots we put out per acre and ultimately our sampling percentage. Here's some guidelines that you might use when laying out your plots. A good starting place is to space your lines 5 chains apart and your plots within those lines 2 chains apart. Now, a chain is a unit of measure commonly used in surveying and timber cruising that's 66 feet. When we space the lines 5 chains apart and the plots 2 chains apart, that will give us a sampling intensity of 1 plot per acre. If we want to increase the sampling intensity, we might decrease the distance between those lines by half. That is 2.5 chains between lines, while keeping that 2 chain spacing within lines. This will effectively double the amount of plots that we put out per acre. So from 1 plot per acre up to 2 plots per acre. Remember, we're going to want to do this more intense sampling when we have variable units that maybe have patchy timber or just a lot of variation. Once we've determined our plot layout, it's time to get out on the ground and measure some trees. So as we travel along our lines using a compass, we'll go our 2 chain distance from plot to plot. Once we get to that plot, we'll establish what's known as our plot center and lay out our circular plot using whichever plot radius is appropriate for the size of plot we're using. We'll measure every tree that's within that plot. There are several different tree characteristics we might want to record at each plot. You'll have to decide which characteristics are important for you given the objectives of your inventory. Some things you might want to measure include the tree species, the tree form, that's the shape of the trunk, tree diameter, tree height, the growth rate of that tree, and any defect in the tree. There are several tools that can help you efficiently measure trees at your plots. A logger's tape, sometimes known as a Spencer tape or a bucking tape, can be used to measure the diameter of trees, and also to measure the distance from trees. This is needed sometimes when you're measuring the heights of those trees. You can also use a logger's tape to measure the plot radius at your plots so that you know which trees are in and which are out. A clinometer is an optical tool that's used to measure slope and angle. It can be used to measure the slope of a hillside or a road, but it can also be used to measure the heights of trees. A Biltmore stick is a stick that's calibrated to allow you to use it to measure tree diameter and also tree height. An increment bore is a special drill that's used to extract a core from a living tree in order to determine its age and growth rate. Tree ID books can also be useful if you're not familiar with all the tree species in your area. And a compass, while not really a tool for measuring trees, is pretty essential when laying out plots to make sure that you stay on your lines. Let's go into some detail on how to actually take some of the common tree measurements we use in a forest inventory. One of the most basic and important measurements we can take of a tree is its diameter. When we take a tree's diameter, we normally refer to the diameter at breast height, or DBH. This is the diameter of the trunk of the tree at 4.5 feet off the ground. This measurement can easily be taken using a special tape measure that's calibrated to directly read the diameter of the tree. We can also measure a tree's diameter using a Biltmore stick. Now, as I talked about earlier, a Biltmore stick is specially calibrated so that when you hold it 25 inches from your eye, it will give you a direct reading of the diameter of the tree. Tree height is another important measurement you can take using your Biltmore stick. To use your Biltmore stick for tree height, you need to be 100 feet away from the tree, and the Biltmore stick needs to be 25 inches from your eye. Simply align the bottom of the Biltmore stick with the bottom of the tree and directly read the tree's height on the Biltmore stick. You can also use a clinometer to estimate a tree's height. To do this, measure your distance from the tree using your logger's tape, and then find the percent slope to the top of the tree and to the bottom of the tree using your clinometer. Once you have these two angles, you take the difference between the two and then multiply that difference by your distance from the tree. So in this case, we find that there's a 48% slope to the top of the tree and a minus 42% slope to the bottom of the tree. The difference between these two is 90%, and we take that 90% and multiply it by 80 feet, our distance from the tree. This gives us a tree height of 72 feet. A tree's growth rate and total age can be determined using your increment borer. When you extract a core from the tree, the rings nearest the bark indicate recent growth. Often we'll be interested in the past 5 years of growth. Another useful tree attribute we might calculate is its basal area. Basal area is simply the cross-sectional area of a tree measured at 4.5 feet high. You can think of it as cutting a tree off and leaving a 4.5 foot stump, and then taking the surface area of the top of that cut stump. This isn't measured directly, but rather it's calculated using the tree's diameter. For example, a 14-inch diameter tree will have around 1 square feet of basal area. Now, basal area is often used when we're discussing the stocking level of a stand. For example, we might say that a stand has 180 square feet of basal area per acre. A more dense stand with more wood might have 250 square feet of basal area. Using the knowledge from this module, you should be able to carry out a simple forest inventory on your own. It's important that when you're designing and carrying out your inventory, you make sure that the knowledge you gain from it will be useful to you as you carry out your management activities. There are lots of other resources you can go to get more information on conducting an inventory. These include workshops and courses from Extension and also several publications. There are times when it's best to bring in a professional for your forest inventory work. A professional forester can carry out an accurate cruise and appraisal of your forest resources. When you're selling timber, it's important that you know the value of your timber before you go to sell it. Foresters can also provide an accurate timber appraisal. This can be important for estate planning purposes. Professional foresters can also give more accurate numbers and growth values that can be useful in your management planning. So far, we've been talking about how to measure trees as they stand in your property. We're going to shift gears here a little bit and talk about how to measure those trees once they're turned into a product that you sell to the mill, that is, logs. Now, how we measure your forest products is going to depend a little bit on what the end product is. Your logs might be turned into lumber and plywood, chips or biomass, or they might be turned into firewood. First, let's talk about logs that are used to make lumber and plywood. Normally we call these saw logs. Saw logs are usually measured using the Scribner log rule. Now, the Scribner log rule was developed back in the 1800s, and it can be thought of as an indicator of how much finished product is going to come out of each log. Scribner log rule is used by measuring the small diameter of each log and the length of those logs. Since it's based on the small diameter of a log, the Scribner log rule ignores all of the wood outside the scaling cylinder. The unit of measure in the Scribner log rule is the board foot. You might remember from high school shop class that a board foot is a volume of wood measuring 1 foot by 1 foot by 1 inch. Now, it's important to note that 1 board foot of Scribner doesn't necessarily yield 1 board foot of lumber. The Scribner log rule is simply the unit of measure used to measure logs, whereas the board foot is used to measure the finished product. Now, back in the 1800s, when the Scribner rule was developed, there was a pretty close 1-to-1 relationship between Scribner log rule and the lumber output of the mill. But since that time, sawmills have become more efficient and logs have generally gotten smaller. Nowadays, a mill could expect to produce perhaps 2 board feet of lumber for every 1 board foot of logs that go in. This difference is known as the mill's overrun. Now, are you as a log seller being ripped off by selling your logs in Scribner while the mill sells their lumber by the board foot? Well, not really, because mills take this difference into consideration when deciding how much to pay for logs. The cubic log rule, while not as commonly used as the Scribner log rule, is being used more and more. This rule is a more accurate indicator of a log's fiber content because it takes into consideration the diameter at both ends of the log, rather than simply the small end, as in the Scribner log rule. The basic unit of measure under the cubic log rule is the cubic foot, simply a piece of wood measuring 12 inches by 12 inches by 12 inches. Let's talk a little bit about the process used at the mill to value the logs that are sent in. This process can be broken up into 2 processes, scaling and grading. Scaling is the process of determining the volume of the log. This is where they apply either the Scribner log rule or the cubic log rule. To do this, they take into consideration the length and diameter of the logs, but also the straightness and decay of the logs. That is, if a tree is very crooked or contains decay, they might deduct from the volume of that log. Once the volume of the log is determined, that log is then graded to determine the quality of the log. When grading a log, knots, ring width, and the general pattern of the grain is taken into consideration. Now, there are different grading standards for different species and for different wood products. When logs are destined to be chips, paper pulp, or biomass, they're generally not scaled under the Scribner or cubic log rule. Instead, they tend to be sold by weight or tonnage. Now, the weight of wood products varies a fair amount depending on its moisture content, and the moisture content of wood will vary throughout the year. Mills know this, and they generally pay a different rate depending on what time of year it is, but still it's important that you minimize moisture loss in the logs that you're selling by not leaving them decked up too long and by moving them quickly to the mill. Wood sold for fuel, firewood, is generally sold using a unit of measure known as a cord. A cord is defined as 4 by 4 by 8 feet of neatly stacked wood. This ends up being 128 cubic feet. It's important to note that when you're selling firewood in Oregon, a cord is the only legal unit of measure allowed. Alright, in summary of this module, a well thought out inventory can help you manage your woodlands more effectively. That's because an inventory helps you to know what you own, where it's located, and what changes need to be made to your resources in order to achieve your goals for the property. For more information on the topics we covered in this module, check out some of the extension publications like EC 1127, Measuring Timber Products Harvested from Your Woodlands, EC 1190, Stand Volume and Growth, Getting the Numbers, and also consider attending workshops and classes through your local extension agent. Also, consulting foresters can be valuable sources of information when you're thinking about conducting an inventory on your property. Thanks for joining me for this module. I hope it's been useful and that it'll help you manage your woods more effectively.